Okay, classwork 3.6. Solving log equations. The first situation you might run into is you have the same base logarithm on both sides of the equation. If that's your situation, then basically just that means that these insides are equal to each other. So I'm going to go over to where I have the answers nicely typed up and make sure you understand that if that is what you see, you're just going to take the two insides and set them equal to each other. And I'm hoping that makes logical sense because you're looking at log base b and log base b. They have to have the same insides if they're going to be equal. So let's look at an example. Number 1. For number 1, you have log base 2 of something equals log base 2 of something else. If those log base 2's are going to be equal, then their insides must be equal. So you're just going to take the inside of the left, the inside of the right, and then solve that equation. And I'm subtracting x from both sides. And then I am getting divide by 4. And I have what looks like a solution. Now I'm going to give you a tip about what it is that matters. You can get extraneous solutions. But here's the thing. If you take the answer you got for x and you go back and you plug it into the original x's, logarithms are only allowed to have positive numbers go in them. You get extraneous solutions when you plug an x in and it creates a number that is a negative number. So is 3/4 plus 3 a positive number? Yes. Is 5 times 3/4 also a positive number? Yes. You don't need to write anything down. You just need to do that quick mental check of, is it creating a positive number to go in the logarithm? It's not about whether the answer is positive or negative. It's about when you plug it in, does it make a positive number go in the logarithm? And so since it only makes positive numbers go into logarithms, that is a correct answer. It's not extraneous. Dun, dun, dun. Number 2. For number 2, you're going to find that you will have the situation of log equals log if you multiply both sides by the denominator. So if I multiply this denominator over to the other side, then I'm going to have log 2x equals log 3x plus 2. Can you see that there is no base number written on those logarithms? When the base number isn't there, oh, yeah, let me address real quick what I just saw in chat. I accidentally I uploaded the wrong document into the 3.4 corrections. I'm giving you an extra day on that. I don't know if you noticed that, but I'm giving you an extra day to turn in 3.4 corrections because I put the correct document on that assignment this morning. So yeah, I did make a mistake there. And now I'm going to go back to the lesson. Back to lesson. If I don't have a base written, what is the understood number for the base? Thank you. Correct. You got it. The understood base is 10. In this situation, though, I just understand that I have two logarithms, one on each side, and And if they are going to be equal, then their insides are going to have to be equal. And then if I subtract 3x over to the left, and then divide by -1, I get x equals -2. But I have to check my original logarithms. I need to make sure that I am only getting positive numbers to go in. So if -2 is my x, and I put that -2 in here, I multiply it by a +2, a -4 is supposed to go in that logarithm. That means that this is an extraneous solution. And since it's the only one I was able to get out, and it's extraneous, that means there is no solution. Only one of the logarithms has to have a negative input for this to be not acceptable. If I had plugged the -2 in and gotten a positive number, I would then move on and check the other logarithms inside. If all the logarithms are showing a positive number going in, then it is a solution. But if just one of them shows a negative number going into a logarithm, then that is not a solution. So that is part 1. Next, I'm going to do a prep for part 2, and I'm going to go over to the typed up answers. And so this is what I want you to take a look at. If a function goes inside of its inverse, whether it's the quote inverse going in f or f going in the inverse, the understanding is that inverse operations back to back undo each other. And if you undo what was done to an input, you get as your final output that original input. And then if you are dealing with a particular base to the power of x, its exact inverse function, which you can also think about it as an individual operation, just like addition is an individual operation. Know that when you see a logarithm written this way, there's an understood parentheses around. Notice I have log base b, and then this starts. If I have an exponent on my variable, that exponent is included to be inside that logarithm. And you need to understand that there is a parentheses there always, it just isn't always written. I didn't feel like I needed to do it on this side because you can see log base b of x is in an exponent. And you're familiar enough that you know there's a parentheses when something is sitting up in an exponent. These two properties we've looked at already, but now I want to make sure you are very, very clear. There are only 5 log properties that you actually need to know. The 3 rules we recently went over, the rule for when you have addition between logarithms, subtraction between logarithms, or a multiplication outside a logarithm. Those 3 rules plus these 2 rules are the only rules you really need to know. You can do everything you need to do with logarithms if you understand those 5 rules. These two are rules based on the property of being an inverse. These are inverse properties. The other ones are based on exponent rules with the idea of inverse. These are just full-blown the inverse. Now, that was the prep for how you can go about solving log equations where you have log of some base with an inside equal to just a number. And I want you to watch carefully what I'm doing here. Watch carefully. Right here you see log base b of x equals a. The way that I process this is the inverse of log base b is b to the power of. If I b to the power of both sides of the equation, then I can see these side-by-side operations that undo each other. And on the left side, I just get whatever was inside that logarithm. On the other side, the b to the power doesn't have anything to cancel with, so it is staying b to the power of whatever number you had. Any way that you see fit to go from this expression to this expression, any way that you see fit is fine to use. This gets explained in different ways. I personally think it is very helpful to understand that you're actually just bringing in an inverse operation. And the more you focus on the fact that this is an inverse operation, the more logarithms are going to make sense over time. So with that said, we are ready for some examples. And it is now 11:10, and this period is over in 5 minutes. So what's going to happen is I am going to make another video that goes over how to do these last examples. I do have some written out work as well. I'm going to make that video during lunch today and get that uploaded for you. But right now I am going to stop recording.